In my last episode, I discussed about the classification of matter. Today, I am going to discuss about the distinction or differences between the compounds and mixture, giving some examples. Compounds and mixtures. Compounds are always homogeneous. But mixtures can be homogeneous or heterogeneous. Heterogeneous. Can be homogeneous or heterogeneous. The constituents homogeneous and heterogeneous means when homogeneous means having the same composition throughout the mass, and heterogeneous means different composition throughout the mass or bulk of the substances. In compound, the constituent can only be separated by chemical process. Constituents can be separated by chemical process only. The mixtures, the constituents can be separated by simple physical process. Compounds, the constituent can be separated by only chemical process. In mixture, constituent can be separated by simple physical process. For example, chemical process, example we can say electrolysis. For physical process, examples are filtration. Electrolysis, filtration. Third one, in compounds is always homogeneous because its molecules are made up of two or more kinds of elements, atoms of two or more kinds of elements which are chemically combined. But in mixture, this is simply mechanical mixing when molecules of two or more elements, two or more compounds mixes with one another by simple mechanical process. So, let us discuss the matter taking some examples so that you people can learn it well. Air is a mixture. Why it is called so? Air is a mixture. Why? During the earlier era, it was believed that air is not a mixture. Air is a compound, or air is simply a pure substance. But in the modern times, it has been proved that air is not a pure substance, but it is a mixture. But it is a mixture. Why it is called so? Why it is called so? Because there are larger constituents of air are two gases. Number one, nitrogen, and number two, oxygen. Nitrogen and oxygen together constitute almost 99% of total air. Near about 78%, 78.1, 78.1, and 20.9% is oxygen. That means almost 1/5 of air is oxygen. Remaining 1% contains carbon dioxide, rare gases, carbon dioxide, rare gases, smoke particles, dust particle, moisture, that is water vapor, etc., etc. So although it appears to us that it is the same composition, that it is homogeneous in nature, but basically these components are variable from place to place and also seasonally variable. And second thing, in case of compound, we have seen that once the atoms of different kinds of metals combine to form molecules of a compound, they lose their own identity. That means the constituents of a compound, constituent atoms of the molecule of a compound loses their chemical identity. But in air, the different elements or compound which form a mixture, they retains their own identity. In identity, the constituents retain their own identity. For example, oxygen. Oxygen is a supporter of burning, and nitrogen is not a supporter of burning, but it sometimes burns itself. Generally, it is almost inert in nature. Burning ability is very, very low. So oxygen is a good supporter of burning. So when we burn a matchstick, it burns well because of oxygen. And carbon dioxide gas helps to extinguish the burning process. Carbon dioxide and nitrogen. If we take some water in a glass, very much cold water, that is, cold means ice cold water in a glass of water, and it is placed on a table, sometimes it is observed, this is a glass, sometimes it is observed some water droplets on the surface of the glass. This proves the presence of moisture in air. That means in air, the constituents do not lose their own identity. So air, which generally appear as compound because of its homogeneity, because of its general homogeneity, but it is actually a mixture. Another proof can be given that air contains carbon dioxide. How to prove? Air also contains carbon dioxide gas. If we take lime water in a bowl and kept in the open air, it turns milky. Lime water turns milky in the open air. This also proves that air contains carbon dioxide gas. That means various constituents of air retains their chemical identity. Another proof in support that air is a mixture is the constituents of air can be separated by physical process. For example, nitrogen, oxygen, etc. can be separated by fractional liquefaction of air. Fractional liquefaction and then evaporation. So constituents of air can be easily separated, their chemical identity retained, hence air can easily be called a mixture. But what about water? Chemically we know water is made up of water, means actually distilled water, not tap water, because distilled water contains impurities like dust, because tap water contains many impurities like rust particle, etc. Water from lakes, rivers, etc. contains various types of impurities. But the purest form of water is distilled water. So when we say in chemistry about water, we generally mean to say distilled water. So distilled water, or simply water, made up of its molecule made up of two types of particle. Molecule made up of two types of particle. Two hydrogen atom, two hydrogen atoms, and one oxygen atom. One oxygen atom, which are chemically combined. But after combination, they do not have their chemical identity retained. How to prove? In general, oxygen gas is a good supporter of burning, but do not burn itself. Oxygen gas is a good supporter of burning or combustion. but do not burn itself. Do not burn itself. Next one, hydrogen. Hydrogen. Hydrogen gas does not support burning, but it burns itself. If a matchstick, burning matchstick held near a gas jar containing hydrogen gas, after some time it is seen that the matchstick extinguishes, but gas is burning from the mouth of the gas jar. And the opposite thing happens in oxygen. That means the matchstick burns with larger flames, but gas remains intact without burning itself. So these are two properties of hydrogen and oxygen. But when they combine to form water, a new substance, water is formed. Water is formed which do not support burning. It neither support burning nor burn itself. That means oxygen is a good support of burning, but water do not support. Hydrogen burn itself, but water does not burn itself. Hence, in water, the properties of hydrogen and oxygen are not retained. And in water, the composition, molecular composition by volume is fixed. Composition of hydrogen and oxygen by volume is fixed 2:1 by volume. 2:1 by volume. By volume. And 1:8 by mass. The composition of hydrogen and oxygen in water, the composition. Another thing, the constant hydrogen and oxygen of water, constant of water, hydrogen and oxygen cannot be separated by physical process like filtration, etc. It can be separated by electrolysis. Electrolysis gives two gases. Electrolysis of water gives two gases, hydrogen and oxygen. That means constant can only be separated by the process of electrolysis, which is a chemical process. And vice versa, if two gas mixtures taken in a gas jar and electric spark is introduced, water droplets are formed. That means for formation of water requires chemical process, and for disintegration or separation of constant from water also requires a chemical process called electrolysis. Hence, depending upon such properties, such discussion I have made today, water can easily be termed as a compound, not a mixture. Thank you people, I am concluding for today.